Hunter mentioned the Raspberry Pi. There's also Arduino. This is really a full computer. You know, it just is the board from inside a cell phone, right? And what this is it's about $35, $40. And it comes from the UK. The Arduino folks are here. But it's really from that maker movement. Remember the clock when you were a kid and you could see through the back of it and you understood what it was? So how do we get American kids and all kids around the world to stop just consuming? But how could they see inside this and begin to break it open and participate with it and become makers, not just consumers of these things? And so I'm going to just pass this around, and we have some great show and tell. So our next proposal is in the line, but it's even more wild than Raspberry Pi and Arduino. And so Theresa Condor is going to talk. I'm not going to tell them exactly what you're doing, but there's hundreds of thousands of jobs open in our country in the STEM fields: science, technology, engineering, and math. And for some reason, our youth just opt out. Some of the research is showing that part of it is they don't really understand what these jobs are about. They don't see the connection between kind of this math puzzle the teacher's asking them to do, or this history of science book they're reading, and really doing science. And really, feeling what it is to not know something and discover it, and feeling what these amazing kinds of jobs that we all get to have on the tech side that we love, and where we really have, I sometimes call it heroic engineering, deep impact on the world. And so the next proposal has to do with how we're going to inspire these folks. Come on up, Theresa.
Hi, everyone. Good afternoon. Let's see if I can get it. So I wanted to start off, again, by mentioning President Kennedy and the moon landing, but from a slightly different perspective from the two other mentions that we had about it already. Not about the event and the accomplishment itself, which was amazing, but the inspiration that it created. So we accomplished this in America, and there was a whole generation of students that got excited about it and went on and grew up to become rocket scientists. And I think there is a sense today among a lot of people that this kind of national cohesive effort towards space is something from history. And so my organization, ArduSat, thinks that that needs to change, and that we need to engage students really early on to get them excited about space and to drive a whole new generation to go in and study science and technology. And our solution, our dream for how to do this, is a satellite for every high school student in America for $250. And now I want to give you a couple of examples of what this actually means. It means hands-on project-based learning across the hard sciences and with computer programming overlaid across the top. So I'm going to click through pretty quickly a couple of concrete examples. So one of them, a student can use the onboard magnetometer and collect data on the Earth's magnetic field and create their own picture of it using real data. They can prove Newton's law of gravitational force. They can measure crop changes or deforestation over time. Or another example is measuring greenhouse gases across seasons and across cities. And these are just a few of the possibilities. And so now I wanted to give you some data about why these type of experiences are actually quite important for inspiring students. And we already saw some other data that came from Neil, and you've probably heard that the US, or that China is now producing more patent applications than the United States, and that they are graduating more than twice as many science and engineering students than in the United States. But I think this data is even more shocking, actually, because it shows that this is not just really a problem of capability, it's primarily a problem of interest and excitement. And the thing is that copying definitions from a textbook for homework just doesn't do it. And we think that being able to program a satellite and being able to collect real data from space is something that might. So here's a picture of our first satellite, ArduSat-1, and this is a list of the more than 20 sensors that are on the satellite that students have access to program and control. And what we're talking about doing here is something that even just a couple of years ago wasn't really possible to do on a widespread basis. There have been a number of forces in the past couple of years that are starting to really make this possible. And the first of them is the maker movement, or the do-it-yourself movement, that you've already been hearing quite a lot about. And one of the things that we do is that we take these kind of sensors that can be purchased at any kind of consumer electronics shop like Radio Shack or on the internet, And that list that I just showed you, I have a little kit sitting over there actually. We take those sensors and put them on the satellite and allow students to control them. The next thing is the CubeSat standard, and that's the type of satellites that we make. This is a picture of our third satellite. This is being launched next month and is a rendering of the actual size of the satellite. And now the CubeSat standard is something that has been driving innovation and specialization around it, and this in particular has dropped the price point, and in particular when it comes to launches. So these type of satellites can actually fit into something that's akin to a shipping container for space. And so they can ride along on more than a dozen launch vehicles across the world. So getting them up into space is much less harder and much less expensive than you would actually think it is. And then the third thing is Moore's Law. Just like the personal computer kind of eradicated the mainframe, and now we consider a PC or a laptop something that is pretty much essential for education, we now have the same thing happening in space. So before, where we had satellites that were the size of an elephant and cost $500 million, we're now getting down to satellites that are the size of a wine bottle and less than $1 million to build and launch. And so we have been taking advantage of all of those forces and are actually putting up satellites for students. And I think this is probably the most important slide here, and this is going to give you the full picture. So what we do is we operate a whole constellation of satellites, and then we operate the associated ground stations. So from the back end, we manage all the communication and the operation of the satellites. And all that students need to do is log on to the internet. They send their commands to the satellite over the internet, and then they download data back again from space that we push to them in the background. And here are some pretty interesting numbers about what it would actually take to give every high school student in America this opportunity. So if we're assuming approximately 15 million high school students in the US, we think it's entirely reasonable by the end of the decade that we can have 100 satellites, it would be 20 launches a year and $100 million, and we could give this to every high school student in America. In the end, we have the technology and we have the passion. And the main thing is that we need the political and the financial will to make something like this happen. And to really give students that inspires them, that want to help them innovate and to be excited about being part of what is going to happen in the US over the next generation, and to study science and technology. Thank you.
Great. Before you go, we're going to do the same thing. Thank you. God, that makes me want to go back to high school, seriously. No, my kids are headed towards high school now, and I just think first robotics or nothing, or boredom. So I can't wait for there to be many things like that. Before you sit down, just so that they have something to think about, they'll do yes and, yes but as described. But is there something that you wish that they would focus on? Is it, how can 15 million people use 100 satellites simultaneously? That's probably not the problem.
I can tell people how the answer to that question, yeah.
No, don't solve that problem for them. I'm asking, what problem would you wish they would work on that you feel like you need help with?
I think the biggest thing is, number one, how we can make this happen financially, and then how we actually get it into the schools. So you have schools that have no money, and you have a bunch of teachers that are overworked, and that quite frankly a lot of them are not actually trained to do astronomy or physics and are intimidated by it. And then they have no budget, and then we have, next generation science standards are coming up, but there still are standards that this needs to fit into. So I think from, again, an organizational perspective of figuring out, everyone is excited about it. We have tons of teachers in schools that want to do this, but how do we actually help them put it in an easy way into the classroom and something that can then be paid for?
Awesome. Thank you so much. That was great.